Welcome to episode 8. Yes, we have finally got out of all of the drudgery of C++, well, basics, and getting our lovely things together. So we have our object loader, the model base, the texture, the model that's been textured. We also have our maths. We've got everything we really need to go for our first entity, I think. Yeah, because what we've been doing so far is everything to capture what OpenGL's been doing. Now we want to start giving the user something to work with, and we'll use an entity system. These can be very complicated. Nah, let's have something simple. Why not? So we can go away from test. I'll just go back to Amber SL here. Save it out. And there we go. As you can see, our program does this. It's just reading out how many lines are in the body.obj file. We gave it a texture number 1, and it's showing that. So, yeah, that's working nicely. There we go. Press return, get rid of that. Let's get rid of all of that. Done with JSON yet, modified. Good. Let's go into the source files now. We've got our maths and our models. We need a new folder. We're going to call it entities. Yep. And in entities, we can have a new file. Entity.h. Yeah, that'll do nicely. New file. Entity.cpp. That's looking good to me. Right, this is possibly a standard way of doing things. I'm not sure, but it certainly is a simple way of doing things. So we'll just pop our include in here for... I've done it again, haven't I? My bad. I keep doing this and I don't know why. Small e, please. Naming conventions. If you choose one, stick to it. Just makes my life difficult. Yeah. There we go, entity.h. That'll be fine. Absolutely fine. No problem with that. There we go. It's starting to catch up with me. Yeah, that's looking good. Let's take that one. Hash include entity.h. Entity.h is a paragma once. There we go. And namespaces. It's pretty obvious. Oh gosh, no, I don't like you doing that. No, don't do it for me. What are you doing? I'm just a simple person. Don't do weird stuff for me. And it's entities, isn't it? There we go. Yep, that's right. Capital E, yep. And we have a class. Entity. Which all of a sudden I can't spell. There we go, class. Magic. That's the structure of entity. The base structure. Let's grab me coffee and start to think. Like putting the semicolon in. And then realising that as I grabbed my cup of coffee, I spelt it totally wrong here. That's probably why I had a difficulty with it. Thank you. Entity. I'll give up on you. You squigglies. It'll come back to us one day. First things first, coffee. Now. What have we made so far? So hash include. We have made /models. We have made a model that is textured. Yeah, we've got one of those. Again, small m. And what else have we made? Well, we've made maths. Yeah. We're going to need a little bit of maths, I'm suspecting. And that will be... just to start off with, I'll just bring in vector 3D, because we're going to definitely need that. This is an entity after all, it's going to need a position. No, that's really just going to be it, isn't it? So let's have... We're now in namespace entities. Okay. So from models, I can have a model that's textured. Yeah, we'll call that model. Let's see, what else can we have? Maths we left just in the amber namespace. I always do that on purpose so that we can just do that. So yeah, as I said, position. So now we've got a text, a model, and a position. So there's basic two things we're going to need, but it's going to need a couple of extras, I think. Yeah. Rotation. X. You're thinking, why aren't you putting this into a Vec3? Well, I could. But for different reasons. It makes the code a bit more difficult to play with, shall we say, if I do. So that's the rotations. They're going to be in degrees. So 360 degrees is a circle. No, there's better reasons why these aren't in a Vec3, but you'll see as we go along, I think. There we go, we'll have scale as well. And it doesn't know what a float is all of a sudden. Go away. Right. That's it. That's all we really need, isn't it? Position, direction, and size. Yeah, that's the basics. Now you're complaining about the line above, not that line. Okay. We should remember that thing. So, public. I think we all know what's coming up now. We are going to do an entity. And we're going to have... oh, I do love doing this. Models. Model textured. Yep. And we're just going to have a model. We are going to have a vec3 position. Is that? Oh. My brain's messing me around on things again. So can you just bear with me as I do go fast and then slow and then fast and then slow and make a complete mess of things. Oh, come on. Here we go, float. We're going to have rotation X. Yeah. The reason I'm doing this is so you can put them in separately more easily. You can make it all look pretty and pretty in vec3s, but I don't want to at this point because it just makes me look, well, it just makes the code look rotation. Yeah, I'm doing it. I knew that this was going to happen. Typos are coming in. What else do we need? Scale, don't we? Yeah. There we go. That'll do. Are we happy with that? Yeah, I'm happy with that. I mean, it's straightforward. It's just set of variables again. It's a storage class, but this time we're going to do a little bit more with our storage class because we're actually at the end of our storage classes. This is it. After this, you're on to things like a component system for your entities, and, well, that's a whole new world of C++, which is not simple. So let's not go there. Let's go to do a couple of things with this entity. Let's increase position. Yeah, let's do that. And we can just use delta x, y, z, can't we? Yeah. So let's float dx, dy. And this is why I haven't used vectors, because I don't know which pieces of information are going to get passed through. So this allows me to interact with the floats separately so that the user can interact with the floats separately without having to worry about vectors all the time or getting it all mixed up. Yeah, I'm going to increase position. Remember, to decrease position is just a negative number, so we don't need a decrease. We can do rotation as well, can't we? Yeah, why not? Again, float delta x, how much in the x direction? I call it delta. Delta means change. change in its mathematical term or physics term, I suppose. It's one of those handy little words that means what it says, change in delta. Yeah, it's Greek. I'm going. It's all Greek to me, you know. Yeah, I think we can have getters, and we can have setters. Can't see why not. What kind of getters and setters do I need? Any? Some? All? Unknown. There's no real way to tell, so what I'm just going to do is I'm just going to make a load of getters and setters, stuff it. Can't see why not. We have models. Model textured, thank you. Get model. Yeah, and all we're going to do is the obvious, which is return underscore model. Yeah. Difficult programming, this. Well, according to the computer, is anyway. Next one's a vec3, so put a vec3 in, and that's just going to be get position. And we can return underscore position. Voila. But what's wrong with my... yeah, I know. I've done it all wrong up here. There you go. Stop complaining at me. Please. Gets me worried when I keep seeing these squigglies. I'm just going to put space in because it looks nice. Thinking how to word it really more than anything else. Let's get this microphone over just slightly. So they're all going to be floats, aren't they? So it's float, get, rotation, X. Does that sound okay? Yeah? We're happy? Return M, rot, X. I wonder why it keeps putting squiggles up immediately on there. Don't know. Let's get on with it. Get, rotation, Y. Yeah, this is looking good. M underscore rot Y. I'm just thinking I could probably copy and paste this, but as soon as I copy and paste, I'm going to make total errors of it all. If I go through it in my mind, it's a lot easier. So all we're really doing is this huge entity storage class, which is going to give us all information about our entity. That's it, won't it? Yeah. So that's X, Y, Z there. Oh, we only need one more. And we can just put get scale, can't we? Yeah, there we go. Underscore scale. There we are. Right. Let's have a look at that. Just double checking myself. Yeah, simple, straightforward, nothing complicated. Getters and setters are the most useful way of transferring, well, the simplest way of transferring data around your program. They're also very, very, very helpful later on. So setters, we have voids for these, don't we? Yeah. So these are all going to be void, and then it's going to be set model. Yeah, we can change the model anytime we want. I can't see why not. Oh, I've got the wrong one. Yeah, that's better. There we go. That's all that needs, isn't it? Yeah, then it's underscore model equals model. This is actually looking quite nice and simple. I'm beginning to like this. Yeah, okay. I am beginning to like this. Set position. This is where it gets a little bit awkward, because we are going to force the user into using Vec3, and I don't like that. But it's the best way of doing positions, because as we bring positions out of this, we're going to need them as Vec3s anyway to do all our mathematics. And it makes so much more sense to use a Vec3 for this part than it does separate floats. It's weird. It just is so weird the way it all pans out in C++. And it's knowing how it pans out, which is what you might call programming experience. I just know that this is going to pan out that way. So our position is going to equal that. Yep, it's looking better. I'm just looking at my... Yeah, I keep spelling things wrong. I don't know why today. Maybe it's normal. Maybe I do this all the time. I just spell things wrong all the time. I just never notice. Oh dear. Bless. Rotation X. That's just going to be float. Rotation X. Yeah. Why not? Can't see why not. So M rot X equals rotation. It's not as if you can't tell what the variables are going to be used for, is it? So, I mean, everything is straightforward. There's no real explanations here. The mathematics behind it all is not straightforward, unfortunately. It isn't simple. It is matrix and vector maths. It will be glossed over. I will not be going in depth, as I've already said before. We're going to let the computer do all of the maths, and I'm not even going to worry about it. I mean, a lot of this stuff, I mean, especially on the mathematical side, I just got off the internet. There's no two ways about it. There's no way you can just make it up. It just doesn't work that way. It's been thought through. It's proper, A-level plus maths degree type of thing, So don't ever get the illusion that I'm making the mathematics up and I'm a genius, because I'm not. I'm just a simple person who knows how to type strange things into a computer. Station Z, is that right? Yeah. Lovely. Coming to the end of this now. How's that coffee doing? Going cold. I mean, as soon as you start programming in this way, you don't really need to be told what to do. It's darned obvious what you need to do. So it's just, where do you need to do like a load of getters and a load of setters? Well, it's usually in this part, the final part, where you want to do all of this stuff. Everything, it's still storage, but this is you brought everything together. So this is everything in one, as it were. What we're doing here now? Scale. Yeah, equals scale. Wow. Can't think of anything else. Just pop that up so we can see it all. Just checking through. Just checking through. And yeah, there's the full class of entity. Awesome. Absolutely awesome. I only need those. Everything else is in here. So that's that. I'm just going to type it in again. Entities.h. Where's it got that from? No idea. It might come from here, actually. How weird. I've never seen that before. Well, never noticed it before anyway. Namespace. Amber. Beautiful name. Namespace. And that's entities. Nice. Control V. There we go. Bring you back for a sec. Right, how shall we do this? We shall do this a simple way, shall we? Which is colon. And that's just going to be m underscore model. Model is equal to a model, comma. Oh, that was a colon, by the way, that I put in between. It's a standard C++ way of doing it. M position, next, is equal to position. And then we're on to the next line. M underscore rot x is equal to rotation x. M underscore rot y is equal to rotation y. Isn't it lovely when it's not really that complicated? M rot z is our rotation. Z, or equal to, should I say? Language the same. And the last one is M scale is equal to scale. You can all guess what I'm going to put in the brackets, can't you? Yeah, I have a tendency to do that, don't I? There we go. And it's all gone absolutely nibbles on me. No idea why. Comma, comma, continue, continue. Model meets model, position meets position. Have I spelled things wrong again? Commas. Interesting. I mean, that's how we normally type it all in. I just splatter it in and I don't care. I mean, I could tidy it up a bit. Make sure everything fits. I can put float on the same line. It's not really that much of an extension, is it? I don't think it's coming through properly. How weird. Disable error squigglies is the fix you give. Okay, what you got? Cannot be defined in the current scope. Yes, it can. No, it can't. Oh, thank you. Because the current scope is freebie. It's got to belong to something. So, will that make everything better? Whilst I'm doing it. Yeah, that makes everything better. Oops. There we go. Yeah, that looks semi-okay-ish, sort of. I am going to bring these back up now. Yeah. A waste of space going on really there. Okay, we'll pop that in. Just split them out, please. Thank you. Alright, here we go. Increase position. This is the more enjoyable bit, I suppose. dx, dy, dz is not going to be that complicated because we've already got a vec3 position going on called M position. So if you take M position like that, and we now are able, because we've programmed it, to do X, Y, and Z using the dot functionality of C++. It's not an address, it's an actual variable, so it's a dot. Addresses are arrows, variables are dots. So .x. We gave it functionality, I hope, to do dx. So all we're going to do is add dx to position .x. Simple as that. Yeah. So what that statement really says is m position dot x equals m position dot x plus dx. That's just an abbreviated shorthand notation. Shouldn't really use them, but does it matter? It looks a bit weird, but just makes it easy for me to type it in, actually. I think that's the whole idea of having the shorthand abbreviation thing is. Z, please. Yeah, it's sort of working nicely. I love it when it works nicely and everything just comes up as you program it. It's just lovely. That's it. That's how you increase a position. Now rotation, yeah. As I said before, it's in degrees, it's 360 degrees. Well, you've got limitations, you've got boundaries there. Increase rotation. What's this about? You can't give me an idea of what squiggly's wrong? Come on, tell me what squiggly is. Show fixes. No. I don't know. I don't know what those squigglies are. Entity color. Increase rotation float dx dy. It's there. Got it. Got it. Wish it had just told me. Right, let's just look at dx. So it's the same, isn't it? So it's m underscore rotation of x. It's no dots because it's just rotx float. So it's dx. There you go. But there's a problem. And the problem is that if our rotation, or mrotx, is greater than or equal to 360, it's a float, I called it a float, then the rotation of x has to minus equals 360. So I don't know how far past it's going to go. I can't set it to 0. So we're just going to have to take 360 off it to keep it within bounds. Simple as. That again is shorthand abbreviated way of doing an if statement. That should be curly braced, but C++ allows us, actually C I think allows us to do that. Just makes everything more compact and, well, to be honest, if m, you can tell what's coming up now, is less than or equal to a 0.0f, I can leave a bracket there, can't I? Then m, I'm desperately trying to put ROY for some reason. We just do the opposite. Plus equals 360.0 f. Yeah, that's it. That's the whole functionality of this function, I suppose. So we can do, you can tell what's coming up already, can't you? So let's just put these in. So that's Y. Program analysis was. Capital Y's. And Z's. Programming can be repetitive. Now you know why I didn't want to put this into a vector. Could you just imagine doing this with vec.z's everywhere? Vec.x is everywhere. It doesn't make it easy, put it that way. This makes it look easy, and it is easy, but it also, we don't need vector equations for our rotations just yet. That will come later. Right, we have our rotation X, Y, and Z. Double check. Lovely. And that all fits on one screen. Perfect. That's a happy function. Happy functions fit on one screen. Entities is a happy thing. It's an object. In C++ we call it an object because it has this constructor. No, destructor again, you might notice. That's because what we have in the constructor needs to be destructed separately. Yeah. You might have noticed a lack of destructors so far. Well, if you're a C++ programmer, you will have done. And it's all done on purpose. Don't put them in, whatever you do. You might be tempted to. Don't. Please, please, please. Don't. Right, that's entity finished. That's it. It looks more complicated than we've done before, but is it? Really? Is it? Nah. There we go. We can now list entity as part of this. So we have now got source, entities, and lowercase entity dot cpp. Go there, put the slash in. That slash means continue line, by the way. Continue on to next line. In Qt profile language. I don't know if it's used in any other language. I've never looked, to be honest with you. Entities is now coming for us. And it's entity, yeah, .h. I like the way it picks up on itself. That's that done. And it's now part of our programming. Okay, we do have a problem with it. I'm not sure what it is yet, but entity, there it is. I always try building it just to see what comes up at the bottom. Code 2 means I've spelled things wrong. Which is typical of me. There it is, it's added, entity.o. That's all been added, so whatever we've programmed in there has been accepted. No errors in that lot, we hope. Trying to think if it's worth... No, it's not really going to show us anything at this stage. In fact, at this stage, I am going to start clearing out our test because our test is now becoming a bit useless. And we know that our program is working. So everything from there can go. Everything in there. You can see how it automatically comes up with all these little red squigglies, which means that amber is really, really working nicely. I'm not doing a test for this one. I just want to get on with it and get through the entities and get them all built. Into there. It should just be back to our base. It says it should be just back to our base. What has it done? Nothing. It says that we haven't changed anything. Oh, it does this because of incremental building. I told you it can cause problems, didn't I? Get rid of that. Get rid of our test app. And just to make sure, let's just make sure I changed it in JSON. No, I didn't. God, I'm an idiot. Helps if you change that. Terminal. Come on, you. There we go, that's what I want. I want a clean test. I just want this in Amber SL now. Yeah, that's nicely done. That's nicely done. That's nicely done. Get rid. Blank everything off. And that was entity complete. I'm not putting tested here, I'm just putting completed. If I type in tested there, it means something completely different. When I have a look at the history files, if I think something should be right and it just says completed, then ooh, I'm not guaranteeing that it's going to work at this point. There we go. Let's pop that onto the server. And I think we're ready for next episode. What's next episode? Oh, good point. Don't know. Let's have a look. Our next episode is going to be camera. Okay, camera next. So be aware that we're going to be doing the camera next. Yeah, simple as that. Let's do that next. All right. So I hope you've enjoyed that little spree into Entity. It's nothing much. No complexities. I'm not doing much more in test now for quite a while. Models doesn't matter. We're just doing entities. So all I'm going to do next is the camera. So until then, you lot take care and have fun.